Everyone. Welcome to our inaugural Learning Labs session. My name is Kirby Koo and I'm part of the community growth team here at Chainguard. And we also have Adrian here today, who is our technical community advocate. Before we get started, I just want to direct your attention to a few housekeeping items. On our right-hand side here, there are a couple of icons. The first one is the chat icon, so that's where you can tell us where you're tuning in from and comment with any commentary. The second icon is the Q&A button. So if you have any specific questions specific to Adrian's presentation, please feel free to raise those questions there. It'll be easier for us to track and make sure that your questions are answered. So we'll get started in a few more minutes. I think we'll just wait for people to join, and really looking forward to this. Great, awesome. Well, thank you so much. I think we can get started. So without further ado, I'd love to introduce Adrian, who is our technical community advocate, and he'll be showing us how to build secure and minimal images with Chainguard's image. Over to you, Adrian.
Thank you. Thanks, Kirby. So welcome to our very first Learning Lab session. This is planned to be a series, so I hope we have many more. Just to give some background, what we're going to be talking about today is building secure and minimal images with the Chainguard static images. It's going to be a reasonably high-level talk with not many assumptions about knowledge. All I'm really going to assume is that you know a little bit about Docker, and you have Docker installed if you want to follow along, and you can do things like Docker run and Docker build. So if you do want to follow along, you'll need a system with Docker, you'll need an editor, and you'll need access to Git, but that's about it. Okay, I think there's quite a few of us here, so we may as well get started properly. So you've heard my name is Adrian Moat. I'm Technical Community Advocate, or DevRel, at Chainguard. I've been involved with containers for, I guess, a decade more or less now. I did a long time ago write a book called Using Docker for O'Reilly, all about Docker and containers. If you want to get in touch with me, you can find me on X, and you almost said Twitter there, on X at Adrian Moat. I'm also on Mastodon and LinkedIn, and you can also just email me at adrian@chainguard.dev. So what we're going to go through today. I'm going to start with a brief introduction to CVEs or vulnerabilities, what they are and what they mean. Then we'll talk a little bit about Chainguard Images, what they are and how they address the CVE problem. Then we're more or less straight into the practical, and I'll show an example image and how we can migrate it to the Chainguard equivalent. We're not going to be using AppCore Melange here, we're just using Docker and Dockerfiles and Docker build. I'll go on to talk a little bit about multi-stage builds, and using a static image. If you have any questions, I think Kirby went nicely through that, but please do ask questions as we go. And I'll stop and take questions at certain points. And also Kirby, I'll jump in if I've missed something or I'm going too fast or anything. Yeah, so please do let me know if you're following along and you get left behind or you want me to clarify something. So I mentioned this before, prerequisites. So if you want to follow along, you'll need a system with Docker installed. I think Podman will also work fine. I've not actually tested with Podman though. If you have basic container knowledge, that'd be really useful. But really all you need to be able to do is run Docker run and understand basically what that's doing. And that'll be more than enough. Excuse me. You'll also need Git installed if you want to get our example code and change branches in it. Okay, so before I go any further, I want to explain a little bit about what a CVE is and why it's a problem for lots of people or organizations. So CVEs, or common vulnerabilities and exposures, are basically known software flaws that have a security impact on applications. Sometimes these can be really significant, and you've probably heard of some CVEs like Heartbleed and Log4Shell. So if you're big and important enough, you can sometimes end up with your own name rather than it's just a random number. And this basically led to the birth of security tooling. So things like Trivy, Gripe, Sneak, and Docker, Scout, and all these tools scan container images for known vulnerabilities and produce a report. So this sounds great, right? And ideally, what would happen is you would have a completely clean report for your images that said there are no known vulnerabilities. But in reality, this tends not to be possible in a lot of cases. And it's because a lot of our base images, especially ones on the Docker Hub, already contain vulnerabilities. And this has kind of left a lot of organizations unsure what to do. Ideally, they'd like to get rid of the CVEs, but they don't really know where to start. And that's where Chainguard comes in. So basically, we're on a mission to try and eliminate these challenges by getting rid of all the CVEs, or all the known CVEs, in the open source software that we all consume. So our images are low to no CVE images, and they're minimal and they're hardened. They're designed to be secure and provide a secure basis for efficient application development. Now, we rebuild these images daily, and we've got images for various ecosystems. So all your programming languages like Go, Python, Node, etc., but also third-party open source like Postgres, Nginx, Redis, and so on. And also options for FIPS images and commercial software as well. I'll talk about, first thing I want to mention is tiers. So everything that I'm going to talk about today is on the free developer tier. So you can pull all the images I'm going to talk about and play with them and do what you like with them. And that's free, but all you get is like the latest tag. If you need like a certain version of an image or an older version of an image, then that's a subscription basis. Also, if you need a special image or FIPS images, that's also a subscription basis. But here on this slide, we have a comparison with some other common images. So for example, if you compare the Chainguard Fluent image to the Fluent Bit image, you'll see that our image is about half the size and no CVEs. With the Node latest image, it's even worse. That's over a gigabyte compared to ours. That's just over 100 megabytes and a lot more CVEs. All these scans, by the way, are with Gripe, and I believe they were done on January the 29th, so a couple of weeks ago. And again, similar story, Datadog Engine, Agent, and Bitnami Kafka. So in all these cases, we significantly cut down or completely eliminate the CVEs and reduce the size of the image. Again, if you pay for production images, then you'll get an SLA on resolving critical and high, medium, or low CVEs. Okay, so the next thing I want to do is basically jump into the practical, but I saw a couple of comments, so is there any questions so far? Oh, there's a complaint about the chart. Was there any questions about the chart? I'm going to blame marketing because it's their chart. Oh, there's a question about Container D instead of Docker. Well, I mean, Container D is essentially a component of Docker now. You can use Container D directly with nerdctl, is it? And that would probably work for a lot of this. I hope that kind of answers the question. Okay, so I'm going to move to this practical now. This is Podman should work fine. So this is the URL you'll need. This is the public repo. We'll see if share this tab instead. Yeah, so if you go to this repo, and there's a code button up here. So you want to follow along, you'll need to clone this repo. And you can use any of these will work fine. I generally do use the GitHub API and that one. Okay, right, let me switch to my terminal. It may take me a second while I figure out the screen sharing. Oops.
Hey, Adrian, we had another question. Resolving critical issues, does that mean you fix them upstream?
I'm not quite sure what the question is asking, but basically, so most of the time, what we're doing is just pulling the latest release. So one of the reasons, and I'll get to this later in the presentation actually, one of the reasons that we have less CVEs is just that we're constantly on the lookout for new releases of software. So if there's a new release of an application, it typically will have that in Wolfie, which is our underlying repository, within 4 hours. Now, some cases, people release a patch, but not update a new release, in which case we'll take that patch and we'll apply it ourselves. And there are other cases still where sometimes upstream doesn't do their own patch, and quite often that's because perhaps it's in a transitive dependency, as in they're consuming like a Go module or something that has a CVE, but their code does not have the CVE, in which case we create our own patch to update that library, for example. Hopefully that answers the question, but I will talk about this again a little bit later. Is there any other questions? Can people read this terminal okay? Please let me know if it's too small. Hoping it's okay. So if you clone this repo, you're going to see something like this. It's a very simple Go application. Now, please don't worry if you're not a Go programmer. It's a very simple application, and we're not going to get into details. But I have tried to lay it out something like a common Go application. So we've got two separate directories, CMD and internal. It really couldn't be any simpler. We've got the main package, which just calls app run server. And we have internal, which just starts an HTTP server on port 8080 that returns hello world. So that's all we're doing. I suppose I can change this to Learning Labs just to show we're live. Oh, now everything's going to recompile, of course. This may have been a bad idea. Okay, so I am running it on a Mac, but I can still compile that locally if I like. I think that should work. Oh, I might be running something in Docker. Let's check. Yeah. So I ran through this earlier, so I'll need to remove this old container. Now, if I run /server, that starts our server on port 8080. I'm not going to bother testing it at this point. What I want to show, though, is the Dockerfile. So this is a very simple Dockerfile for this application. We're using the Golang image from upstream. So this is like Golang latest, and by default, this uses the build tools underlying image, which uses in turn Debian. So this is a Debian-based image from the Docker Hub, and basically the default for Golang development. We're setting a work dir where we're going to do our work. We're copying in basically the source code. I have split it out into different copies. Sometimes that's good practice to support caching in Docker build. So for example, if the Go mod file I expect to change less than the source code, so we copy that in first, and we take advantage of caching a bit better. But yes, it's really simple. All we're going to do is run go build and output the binary to hello, and then we're going to set the entry point to call that binary. So very simple Dockerfile. We'll call it my Golang. So if we run Docker build, and because I changed the code, this is going to take a minute to compile. Yeah, I really shouldn't have changed the code and used the cached images. Almost there. Do I need the server? No, the server was just me showing. It's the same Go application. It's in the Docker file. I was just showing that it runs locally as well as in the Docker build. So that server, I think, is not running anymore. So that's built. I guess the first thing I'm going to do is run it. Got an annoying. Hang on, I'm going to move my monitor slightly just so I can see my whole thing. There we go. Docker run. I don't think anything's running, so I can do port 8080. This -d so it runs in the background, and I called it my Golang. So hopefully that will work. And if we curl localhost 8080, because I exposed port 8080 in localhost and connected it to port 8080 in that container, with any luck, yeah, hello Learning Labs. So that's our application working and running in Docker. But if I run Docker images and take a look at this image, it's 903 megabytes in size. So it's quite a large image. But worse than that, if I run, one of my favorite tools for checking out CVEs is Docker Scout. So if I run Docker Scout Quick View, I mainly like Docker Scout because it gives quite a nice summary output. Yeah, then it tells us it's got various vulnerabilities in this image. And so in this case, we can see there's 43 vulnerabilities currently classified in this image. And we could use other tools, so you can run gripe. What line is the last line? Oh, geez, I'll make it smaller. See if that helps. I don't see it moving. I think this is a crowdcast thing. I'm not sure there's much I can do about the bottom line, I'm sorry. Maybe if I make it smaller the other way. No, I'm sorry. Yeah, I've tried moving it up. Like, this is me moving it up. Oh, no, did it move? Okay, thank you. Right, that does look better. So I can run gripe. And this, for whatever reason, gripe does tend to find a few more vulnerabilities. Honestly, I prefer the Docker Scout output. This is saying it's 358 vulnerabilities, so a lot more. I think quite a lot of these are probably disputable, let's say. And you'll see quite a lot of them are marked as won't fix, which means that Debian have looked at them and decided they're not worth fixing for whatever reason. Okay, but At any road, there's definitely known vulnerabilities in this image. Okay, so if we look at the Dockerfile, the first thing we can do is just change this Golang. So all I'm going to do is remove Golang. I'm putting cgr.dev, Chainguard, go. So change Golang to cgr.dev/chainguard/go if you're following along. And that's the only change I'm going to make. I'm just going to wait a second for people to catch up. It is quite simple though. It's just cgr.dev/chainguard/go. And then I'm going to rerun the build. We'll give it a slightly different name so we can compare it. And that built, thanks to the caching, it was a little bit faster. Okay, so now if I run, well, let's first check it runs the same. I still have the old image running, so let's get rid of Hungary. No, I'm not going to try and pronounce the. Where's that? Oh, not the RM, that's why. Yeah, so we'll run this image. And if I do curl localhost 80, so it's still working. So I've made that one line change, but everything is still working exactly as it did before. However, if I go to Docker Images, it's now 786 megabytes, which is, a decent saving with 117 megabytes or so. But more interestingly, if I do Docker Scout Quick View on my Golang CG, there's no vulnerabilities. So that's a big difference, right? We've gone from, of what Docker Scout say before, 43 vulnerabilities to 0 vulnerabilities, just by changing one line. Oh, we can try gripe as well. Sometimes I have problems with gripe, but we'll try it. This could be the bit where the live demo goes completely wrong. Looking good. No vulnerabilities found. There is about packages missing CVEs. I think that's actually the binary we installed. So I think it's the binary we built. So I don't think that's an issue. It has, I would say it has found 98 packages. So it has found most of the stuff in the image. Okay. So the thing is, that is much better, but it's still 786 megabytes. So it's still quite a large image. And there is more we can do. So this is the slightly more complicated bit if we're following along. We're going to change to use a multi-stage build and use the Chainguard static image. So what this means is we're actually going to have 2 image builds here. And in the second image build, what I'm going to do, so I'm going to use the static image, and I'm going to copy from the first image, and I'm just going to take the hello binary and put it into this image. And then we can set the entry point. Well, I'll just copy that one actually. We can set the entry point to /hello. We're not using the work directory anymore. So the other thing I need to do is set this to as builder. So we'll give this a name, which is what we use to refer to it later. And the final thing I need to do, and this might seem like magic, but is very important, is I'm going to change this line to say cgo enabled equals 0. What that's going to do is going to tell Go to build a statically linked binary rather than a dynamically linked binary. If I hadn't done that, this wouldn't work. You'd get this binary wouldn't start up because it'd be missing some essential libraries. But by typing cgo enabled equals 0, we've told Go to build a binary that has all the dependencies it needs, including the libc bundled inside it. In some cases, you may find you need to pass a little bit more than CGO enabled, and there's a link on the final slide that talks a bit about and what cases those are and what the flags you need to pass are. But in this case, just passing CGO enabled equal to 0 is enough, and I think it's probably enough in the majority of cases. Okay, I think that's about it. We'll see if I've made a mistake in a second. If you're following along, add this as builder line, or this as builder text, the first line, add CGO enabled equals 0 to this line, and add these lines from cgr.dev/chainguard/static, the copy from builder, and the entry point. So just to be clear, the static image is a very small image that just contains enough to run most applications. So it's a little bit bigger than like the Scratch image. Scratch is the completely empty image that has nothing in it, but the static image has a little bit more. In some cases, you can get away with copying binaries into the static image, but what you typically find is you need one or two things. So the most common one is TLS certificates. We're talking to other web applications securely over TLS. Quite often you need a temp directory for creating temp files. Sometimes you need a user, things like that. And that's exactly what the static image gives you and no more. Okay, so if I got this right, which I don't know, I'm not taking bets, this should build. Oh, I just noticed I answered the question as we went, that's good. Okay, so that built, but did it work? Let's first stop the other image. And we'll do Docker run again. User controller, yes. Oh, I think that's the right image. Now, did it work? Yeah, so that worked. So the really interesting thing now is, I'm going to copy this, it's too much typing. This image is only 7.76 megabytes. So we've gone from 903 megabytes to 786 megabytes to just 7.76 megabytes. So that's a huge saving in terms of space. But the application works exactly the same. So, with this, you're going to have much less, it's going to be much easier to transfer this image about, to copy it to your registry, to copy it onto your nodes. But it's also going to have less attack surface. There's less scope for people to execute living on the land attacks and take advantage of any tools or binaries that might be in the image, etc. So we've improved our security stance, and we've made things much smaller and easier to move about. And we should also do Docker Scout quick view. No, that's not what I wanted. CG-distroless. And this should also be 0. Yeah, we've still got 0 CVEs. Okay, are there any questions at that point? So still, I see a static image supports any runtime. No. So if your language has a runtime like Java, you'll need to use a JRE runtime image, but we have a runtime image for that, yeah, and Node, etc. Right, let me find my slides if I can, and then I'll continue to answer any questions. Yeah, so was there any questions there? Have I missed anything, Kirby? Oh, regarding C++ in that question. So, well, I'll come on to it in a second, actually, but there are, basically, we have variants of the static image that have some more libraries for cases like C++. Are we okay for questions, Kirby? Maybe there's a button I can push.
There's another one here. Docker Scout depends on packages. Do you have packages in distroless?
So I think what that question is getting at is the way the vast majority of vulnerability scanners work is they primarily look at the package repository for your distribution. So if you've got a Debian image, you go and ask apt. If you've got a Red Hat image, it goes and asks yum. If you've got an Alpine or a Wolfie image, and we're based on Wolfie, it goes and asks APK. And basically it says, hey, APK, what packages are installed in this image? And so, yeah, basically Docker Scout does recognize Wolfie and all the packages installed. What was I going to say? What was the question? Oh, it's a boring crypto question. This is going to be complicated. I am not a Go expert, so I'm probably the wrong person to ask. Okay, this gets into FIPS. I'm not going to answer a FIPS question, but I will say that you have to be careful with like FIPS and Go images. It's not actually as simple as just linking the boring crypto library, I believe. But that's a talk to somebody more intelligent than me question. It does also get onto the question on static stuff that I'll talk about in a minute. Okay, anyway, is there any other questions at the minute? We're going to move on to this slide then. So yeah, this is just a summary of what we saw there. We've got the CVEs down to 0 and we've got the size down to 7 megabytes. So it's a huge difference from where we started. So you've heard me say the word static and statically linked and dynamically linked a lot. I realize this is a bit confusing because most people don't have a C background, for example. To try and explain it as succinctly as I can, you have dynamic binaries and you have static binaries. So if you have a VM or a laptop or something and you install a package or you install software, nearly every piece of software shares some libraries, right? Everything uses the system libraries to talk to the kernel, for example. So it used to be that you really didn't want everything to have its own version of those libraries. It was much better if everything used the same system library. And that's why you have dynamic binaries, largely to change size, to reduce size, and to have one place where you keep everything at the correct version. Yeah, so that's what a dynamic binary is. It links against other external libraries. So you can't just copy the binary. You also need to make sure the libraries it depends on are available on the system it runs on. It does get even more interesting because there are certain libraries that are more important than others. On Linux, that's particularly your libc implementation. Static binaries, however, are fully self-contained. So I copy a static binary and it will run on any Linux environment, and it has all the dependencies it needs within itself. Now, one of the interesting things, if you use Rust or Go, Rust or Go code itself is normally just statically linked. Like if you pull in a module, it gets statically compiled into your Go binary. And that's basically true for everything apart from your system libraries. So that's where you end up with Go libraries that are dynamically compiled because they're using various system libraries. And the most important of these are glibc and muzzle. So glibc is basically the standard Linux C library. It's used basically for talking to the kernel. So if you need to create a file, if you need to open a socket, you're going through the glibc or muzzle. But the thing about glibc is you can't really use it within static linking. I'll let you go and look up the reasons for that. We do have various variant images available that I'll show in a second, which do include a few more libraries. So for cases where you can't quite create a static library, but you only depend on one or two dynamic libraries, then that's definitely a possibility. The other one is muzzle, which is used in Alpine and not a lot of other places. Muzzle is basically an alternative C library that you can statically link. So you can say, hey, compile muzzle into my binary. Sometimes there are compatibility concerns. If you go online, you'll hear people complaining about DNS. Really, I'm not going to say, I wouldn't say muzzle is wrong. It just works differently in some cases. There may also be like performance differences, like some things may be faster in muzzle and some things may be slower. Static variants. So sometimes, yeah, you want a not quite static image. You want a few common libraries. So a couple of ones that we have are things like CC Dynamic and glibc Dynamic, which contain a few more libraries. And you can therefore run programs that link against these libraries in those. I should also say that in Wolfie, although we use the same package manager APK as Alpine, our packages aren't compatible with Alpine. And in fact, all our packages are compiled against glibc. They're not compiled against muzzle. So Wolfie and Chainguard Images are glibc based. If you use Rust, I think you'll get away with using a glibc dynamic image. Just to copy in your Rust binary in. Do test that and let me know if it works. But if you can't do that, you can use this muzzle target. And basically that will create a completely static binary with the muzzle library compiled in. And to do that, you're basically going to do something like cargo build -- target, and then your target will end in something like Linux -muzzle. What's distroless? So I'm not sure if I've mentioned distroless so far, but Chainguard images often get described as distroless. So a distroless image is one that contains the minimum number of dependencies. You don't have a shell or even a package manager by default, unless you need one, or unless it's essential for the application to run. So what you'll find is a lot of Chainguard images have like -dev variants. So for example, there'll be Redis latest -dev, and that will include Redis, but it will also include a shell and a package manager that is not present in the normal latest image. And that can be really helpful if you need to install your own package on top, or if you need to just play with it for debugging, for example. I think I still got plenty of time, so I'll do a brief demo on debugging, but is there any more questions here? TensorFlow, okay. Yeah, so I couldn't tell you, like, maybe someone can go and look it up. I think Wolfie might have a TensorFlow package, but I'm not 100% sure. I know we're working on stuff like PyTorch at the minute. But yeah, you can't use the Alpine one. Well, I'm not quite sure what will happen. I think, yeah, I suspect the Python pip for Alpine will include compiled code in the case of TensorFlow, so you'll need a Wolfie version. Kirby, have some more questions?
Yes. On the hardening side, do you make the Chainguard image rootless or remove capabilities as well?
So you can't remove capabilities. That's a question for like the, your Kubernetes or your Docker host. We do add a non-root user. So you should be able to do like Docker, you should be able to pass the user non-root. And I think most of our images run as non-root by default. Also, if you look at things like our Nginx image, that will run on port 8080 and not port 80 by default. So we try, yeah, it's basically exactly that. We try to run as non-root. And in some cases, there's a few other things you can do about volumes and so on. Was there any other questions? Somebody's using Chisel. Oh, so that's a good question, actually. Somebody's asking about Chisel and comparing that to Chainguard images. No, we don't use a Chisel approach. So in Chisel, basically what happens is they take the Debian deb packages or Ubuntu deb packages, and they sort of say, hey, I just want this part of the package. Take a slice of it. It's literally called a slice. And you specify which paths you want from the package. That's not what we do in Chainguard images. In APK, you have this idea of sub-packages. So we just split up our packages into sub-packages by default. So you'll find like dev variants, lib variants, and man page variants. And so wherever possible, we split it up into atomic units. And you just pull in the atomic unit you're interested in. So it's it's not this after the fact idea of going and like taking out paths. It's actually built from the start to be minimal. So I'm personally, I think our approach is a lot better. Might get in trouble for saying that. As far as CVEs goes, Chainguard does have its own security database. Maybe somebody can find the link for me while I'm talking. But yeah, there's Chainguard Images. Okay, occasionally you'll find CVEs for Chainguard Images. We absolutely have a security database. Is it Wolfie? Maybe I can find the link myself. If not, I'm sure Kirby or someone can put the link in.
I can find the link for you, but a new question came up. Are security scanners accurate with those stripped down images?
Yeah, basically. So another thing I should say is that we build our images for something called APKO. So everything in our image comes from an APK package. And so everything in our image is described by the APK database. And sometimes that's not the case for other images. For example, if I compile my own software and I copy it into an image, that won't also always be picked up by the scanner. But for our images themselves, not for the images you built on top of them, but for our images themselves, the full image is basically described by the APK package database. So yes, it should be completely accurate. No, they don't lack any evidence of installed packages. We also have an SBOM. So you're also welcome to go and look at the SBOM. The other thing I'd encourage you to try is if you run gripe on our images, you can tell it to build its own SBOM. So you can look at all the versions of the packages it's found. And you can reassure yourself that it's found all the packages it should have found. I think gripe's also quite good at finding Go binaries and looking at the dependencies in the Go binaries as well. Which is a relatively recent thing. Okay, am I good to move on to the next part of the practical?
Yes, you are. Loving all the engagement, though.
Yeah, no, this has been fantastic. And I'm also really happy that there's so many people here. This is awesome. We've got the right... oh no, there we go. Okay. So there's a couple of quick things I just want to show. The first one is sometimes debugging a distroless image can be a bit annoying. Oh, am I sure? Yes, I am. Sometimes debugging a distroless image can be annoying because what happens if I do, where is it? Docker exec assign elated Thompson, and I ask for a shell. Well, I can't get a shell because there's no shell to be got. There's no bash. It's not at bash. It's not at sh. There's no ping. There's no binaries in there at all, apart from our executable itself, which is a bit of a pain because I can't get in there and look at what's going on. I can't run ls even. So one thing you can do if you use a paid plan in Docker is run Docker debug. So I can run Docker debug, elated Thompson, and that brings me up this. And suddenly I do have a shell. Notice it has this Nix directory. So what's basically done is sideloaded in a Nix container. And it also has sideloaded in a whole bunch of tools. So I've got Vim, I've got ping, and I've got other stuff. And even better, I can actually install any tool I like from Nix. So I can type things like install Emacs, and it'll install that tool. So that's a really nice way to sit and debug things. And you can also, create files and change the file system on that container. So that's one solution for debugging. Also note there's something called ephemeral containers in Kubernetes. And that's very similar to what I just showed you with Docker debug. What you're going to type is kubectl debug. I don't have Kubernetes running at the minute, but basically you would run kubectl debug, and that's going to give you an ephemeral container that attaches to the same pod as your distroless container. So again, you can do some debugging and so on. But the other thing I want to mention is our dev containers and equivalents. So in our distroless container, we don't have a shell and there is no dev variant. So what you would do instead is run Wolfie base. I've not tested this, so hopefully this will work. But basically, Wolfie base is more or less static plus a shell and package manager. So we're still going to end up with a small image, but it will have a shell and package manager if this works. I've not tested this, so this could go horribly wrong. So I want to run this. -it. Oh, and I just set the entry point. Yeah, so now we've got the same image, almost nothing in it apart from our hello binary, but I can get in there. I can also now make the point about static versus, well, I can show you this as a static binary. So I also have APK installed here. So I can run APK update and I can do APK install. CMD tells me, I'm going to type CMD as in command file. So I want to install, sorry. So I want to install the application file, but I can, oh, it's actually just called file. And now I can run file hello. And this tells me I have, the type of executable, but most importantly, that's statically linked. If it wasn't statically linked, you'd say dynamically linked there. You can also run LDD to find out which libraries things are linked against. Last thing I want to show is I use Go here. So this image also, I believe it does have a shell for some reason, but it doesn't have APK. If you did need APK, you could just do Go latest dev and you get an image with APK inside it. Okay, is there any questions there? I'm going to change back to the slides and wrap up. LDD, LDD, just like, I'd have to go into, maybe I can run slightly out of time. So if I take this out, we rebuild it. This is no longer distroless, so I should change the name. I think, did I leave? Or maybe I didn't leave. Yes, I did have dev, cool. So if I run this and get a shell, no, that's not going to work. That's the entry point. So now if I do APK add file, and I do APK add, this is the one I can never remember the name of the package, but LDD is in POSIX libc utils. So I recompiled this time without the cgo enabled. So we should see, yeah, look, dynamically linked. And that's what happens if you compile without cgo enabled. And then if you run LDD, it tells me what libraries it links against. There's some kernel stuff here as well. So this is to do with the kernel putting things in user space. Okay, let me change back to the slides. I'll take any last questions. Cool. Yeah, so we've been through the dev variants, which include a package manager and shell, Docker debug, which can be really useful, ephemeral containers, which is the Kubernetes equivalent of debug, really. One thing I want to quickly go through is how we keep out CVEs. So I think there's some understandable curiosity about how we manage to get to 0 CVEs when other people don't. And this is what it comes down to. One, we cut down on the number of things in our images. So there's just less software in our images to accumulate CVEs. 2, we keep things up to date. I mean, we really keep things up to date. So typically, we're within 4 hours of a new project doing a new release, we've got that new version in Wolfie. And we rebuild images daily, so within a day, there should be a new version of your image with that new version. We also apply patches when necessary. So if we're always running tools like Gripe, and if they turn up CVEs, we'll go and look into what we need to do. Sometimes that'll mean getting a patch from upstream, applying it ourselves. And if we do that, we'll also need to issue a security advisory to tell the security scanners, hey, we've patched the CVE. But by just constantly doing all those things, that's how we get to 0 CVEs. Yeah, so to wrap up, it is really simple to change the Chainguard images. We saw that one-line change from Golang to cgr.dev/chainguard/go. Got rid of all the CVEs and had a small reduction in size. Going further to static had a major advantage in size. In both cases, there was a big advantages in security and you saw security footprint. And there's a really large number of Chainguard images now available. So for the majority of large open source packages out there, you should be able to find an image. Please let us know if there's something we don't have that you would like. And do remember that our -dev variants if you find the distroless versions difficult to work with. Okay, right. Thank you everybody for listening. Is there last questions? There's a question about Slim Toolkit. I'm not sure I quite follow. App developers complain a lot about missing libs. But so the application doesn't work. That sounds terrible. So we don't do that. Like, everything's all our images have all the dependencies. Can I get a specific Golang, PHP, other programming language version? Yeah. So there's like a PHP image, and we're using the Go image there. Yeah, completely. We should have pretty much all the major programming languages. Definitely Python, Java, Go. Was there other questions, Kirby? I'm not sure if I can see the question list.
I don't see any questions that you haven't covered yet.
Cool. Oh, is there a bit on the right? Oh, I see the question button. I found it. I should have looked at this before.
But I did want to add that we'll be running the Learning Labs monthly. So if there's any topics that you want us to cover in future sessions, please comment with them or send us the suggestions on social. And thank you, Chris, for sharing our Chainguard Images directory.
Did anybody share the security advisory site? Basically, maybe I can find that before we go.
I believe Lisa did earlier in the chat.
I think she shared I think it was on the slide. I found it. So we do publish security advisories. The best place to go is, let's ask a question. Can I only ask a question? Chat, here we go. So hopefully you can see that. There's github.com/wolfie-dev/advisories. If you go there, that's all the advisories for our packages. There's also a separate feed that's consumed by the various scanners, but this is what it's built from. And there's just basically YAML files there for all our packages that have the security advisories in them. Okay, yeah, thank you all very much for attending, and I hope to see some of you at the next one. This has been great. Thank you very much.
Thank you all. Don't forget to send us your suggestions for the next one. Thank you so much for joining, and thank you, Adrian. Virtual clap. Have a great day, everyone.